Today we're going to add that first step to our factoring quadratic functions. So if you remember from last class, our first step is to look for a GCF. And if we find a GCF, we're going to factor it out. Our second step is to use the X factor method. Third, we're going to do the box method, which we're going to talk about later. And we really use that when our A is not equal to 1, once we look for a greatest common factor. And then our last step is to write our final factored answer. So for today, we are really just focusing on looking for a GCF and factoring it out. You guys should be familiar with X factor now and the final factored answer. So we're just adding that GCF part. So a greatest common factor is the largest number that is a factor of 2 or more other numbers. So it's important to find the largest number because then when we're factoring, there's nothing else that we can take out. So if we look at the GCF of 6, 9, and 21, hopefully you guys already recognize. So 6 can be written as 6 times 1 or 3 times 2. 9 can be written as 9 times 1 or 3 times 3. And 21 can be written as 21 times 1 or 7 times 3. And if you notice, we have one number in common in all of these. We have a 3 that is a factor in all of them. So our GCF is 3. We're going to look for the highest number that is a factor in all of our terms. Okay, so looking at our first question, we have 8x squared minus 24 plus 16. And if we look at our A, B, and C, we have 8, we have 24, and we have 16. So looking at those three numbers, our GCF is 8. So what we're going to do is we're going to divide 8 out of all of those terms. So we have 8 is outside. 8x squared divided by 8 would just give us x squared. 24x divided by 8 would give us 3x. And then 16 divided by 8 would give us just 2. So we are going to keep that 8, and we're going to bring that down, and that will be in our final answer. But right now, we're just going to worry about this part. So we're going to use our x factor with that portion of our equation, or our expression. So remember that we put in the top of our x, we put our a times c. A times c is 2 in this case, and our b term is negative 3. So what two numbers multiply to give us 2, but when we add them together, we get negative 3. Well, since 2 is positive, we know that they both need to be the same sign, and since our b is negative, we know that they both need to be negative. We know that negative 1 times negative 2 will give us positive 2, and negative 1 plus negative 2 will give us negative 3. So those are our two factors. So we have x minus 1 and x minus 2 are our two factors. Remember, you can always check to make sure that you got the correct answer. So we have 8 And we have x minus 1, x minus 2. You can use the box method, you can use FOIL, you can use rainbows and smiles, but we know that x times x is x squared. We have x times negative 2 is negative 2x. Negative 1 times x is negative x, and then negative 1 times negative 2 is a positive 2. Don't forget we have our 8 out in front. So 8 times x squared minus 3x plus 2 gives us 8x squared minus 24x plus 16. Since this is what we had originally for our function, that tells us that we got it correct. So you can always check by multiplying your factors back through. Let's look at number 2 and the GFC for number 2. If you notice, for this one, we have our A, B, and C, just like normal, and we have a GCF of 3, because 3 goes into 3xy, or x squared y. 3 goes into 39, and 3 goes into 60. But if you also notice, not only is there a 3 in each of them, there is also a y in each of those terms. So we're going to factor out a 3y. When we do that, so remember when we're factoring out, we're dividing out 3y. So when we divide by 3y, our first term, we get x squared. When we divide our second term by 3y, we get 13. Oops. And then when we divide our last one, we get 20. Now we're going to look and we're going to use x factor. Multiply our a and c gives us 20. And our b is 13. What two factors of 20, what can we multiply to get 20 that adds to give us 13? Well, we have 20 times 1. We have 10 times 2. We have 4 times 5. And then we go reverse. We have 5 times 4, 2 times 10, and 1 times 20. But do any of these combine to give us a 13? None of them combine to give us 13. So this one is prime. It cannot be factored. So we would end with this as our answer. And that's okay. If there are no two numbers that multiply to give you a C and combine to give you your B, that's okay. Okay, looking at our next question, we have factor negative 6x squared minus 18x. So again, remember our first look, we're going to look for a GCF. Okay, in both terms, we have a negative 6, and we also have an x in both terms. So our GCF is negative 6. When we factor that out, negative 6x, we get negative 6x, and then inside our parentheses, negative 6x squared divided by 6x gives us just x. And then negative 18 divided by negative 6 gives us a plus 3. And that's as far as we can go with that one as well.